Well, welcome back. In this screencast, we're going to take a look at least common multiples. Now, least common multiples are multiples. They are multiples that numbers have in common. We are looking for the smallest of those multiples that the numbers have in common. That's the idea. So let's take a look. Find the least common multiple of 9 and 15. We will use the intersection of sets method, which is a very similar process to what we used to find GCFs. We're going to list out the multiples of 9. We're going to list out the multiples of 15 and look for what they have in common. The multiples of 9, 9, 18, 27, 36, 45, 54, 63, and so on. This is an infinite set. We cannot possibly write them all out. It is an infinite set. The multiples of 15, 15, 30, 45, 60, 75, and so on. This is an infinite set. We will never write them all, ever, ever, ever. What are we looking for? We're looking for common multiples. Well, there's the first one. And when we have the least of the common multiples, that is the least common multiple. The least common multiple is the first positive multiple that both sets share. So the least common multiple of 9 and 15 is 45. Let's go to a second example. Oh, mercy. Find the least common multiple of 2,860 and 7,480. Let's find the least common multiple of those two numbers, and we'll do it using prime factorization. Well, that's not too bad if you know the prime factorizations. The prime factorization of 2,860, well, there's two factors of 2 and a factor of 5 and a factor of 11 and a factor of 13. 7,480 is 2 cubed times 5 times 11 times 17. So here's what we do. We build the least common multiple. Whatever primes we put here, whatever set of primes we put here, all of these primes have to be enough to cover all of those and all of those. So we have to be able to see 2 2s, a 5, an 11, and a 13 in what we put here. And we have to be able to see 3 2s and a 5 and an 11 and a 17 in what we put here. So it's relatively straightforward. There should be a 5, there should be an 11, there should be a 13 to cover that. There should be a 17 to cover that. We don't need 2 factors of 5 because this one is enough to cover that, and this one is enough to cover that. We don't need 2 factors of 11, same reason. How many factors of 2 do we need? Well, we need enough to cover all of these or all of those. If we're looking at 2860, we need at least 2. If we're looking at 7480, we need at least 3. We choose the bigger of those two numbers because we have to be able to cover all 3 of these if we try. And so this is the least common multiple, which happens to be 97,240. We were not going to figure that out easily by writing out the multiples of those numbers. So just to make sure, take a look here, make sure that in the least common multiple, there are 2 factors of 2 and a 5 and an 11 and a 13. There are. Then take a look here. Make sure that in the least common multiple, there are 3 factors of 2 and a 5 and an 11 and a 17. There are. And so this is, in fact, the least common multiple. You may want to practice find the GCF and the LCM of 24 and 30, 731 and 952. Take a moment, hit the pause button. Answers will show up soon. I told you the answers would show up soon. So those are things to think about. Hopefully you got those answers correct, and if you did, great, then you understand the algorithms, and if not, we should probably talk about the algorithms. Catch you soon.